Here in example 4, we are given a question where we know the sum of the first three terms to be 6. So that's this piece of information here. And the sum of the next three, in other words, 4, 5, and 6, to be 51. And we want to find the general term for the arithmetic sequence. So let me write this information in symbols. I know that the sum of the first three terms plus t3 is equal to 6, and the three consecutive terms after that will give me 51. And because I know it's an arithmetic sequence, what I'm going to do is I'm going to replace each term with its equivalent expression in terms of the general term. So remember once again that the general term of an arithmetic sequence is a plus n minus 1 times d. So I'm going to replace the n with 1, with 2, with 3, 4, 5, and 6 respectively, and then put its expression into both of these equations here. So let's just look at the first one. So I'm going to take this equation and replace all the values. So t1 will just be the first term, which is a. t2 is going to be a plus the first difference. Again, how do I get that? Well, plug in 2 over here, and you're left with 2 minus 1, which gives me a plus d. Very well. The third term, I'm going to get a plus 2d, and I know this is all equal to 6. The second equation, same thing, but instead of starting from a, I start with a plus 3d, and then add a plus 4d, and then add a plus 5d, and this is all equal to 51. So it's not much of a stretch to see that at this point we collect like terms and then bring them together, and we'll end up with two equations. So let's see what happens. For my first equation, 3a plus 3d is equal to 6. And the second equation is 3a plus 3 plus 4 plus 5 will give me 12. d is equal to 51. Both of these equations can be simplified. If I divide each of them by 3, I get a plus d is equal to 2. Then I get a plus 4d is equal to 17. At this point, I can see elimination as being the more viable choice, because a and a, when you subtract them, get 0. d minus 4d gives me negative 3d. 2 minus 17, negative 15. And my value for d is going to be 5. So there's my first term, and I need the a value. Well, I'll take that 5, plug it into, say, this equation here, and see what we get for a. So a plus 5 is equal to 2 implies that a is equal to negative 3. And there you have it. Our a and d term, which we can then substitute into our general equation, which is negative 3 plus n minus 1 times 5.